What about yesterday's homework? Yesterday we have seen unit step sequence. Then we have seen shift theorem. What shift theorem says that z transform of yk plus n is z raised to n z of yk minus summation m is equal to 0 to n minus 1 ym z raised to n minus m. Okay, and then we have seen some examples. We have solved initial value problem also using z transform, and I have given this example. One example you for homework to complete it. So whether you did it?
Yes, ma'am.
Yes, you got this answer?
Yes, ma'am.
K
Yes.
is equal to 2 into 3 raised to k plus 1 by 3 k 3 raised to k. Okay. Okay, so we will go to the next theorem. Initial value and final value theorem. So what this theorem says that theorem 3.16 initial and final value theorem. There are two parts. If yz exists for mod z strictly greater than r, then y0 is nothing but limit z tends to infinity capital Y of z. And B part, if capital Y of z exists for mod z strictly greater than 1 and z minus 1 Y of z is analytic at z equal to 1, then limit k tends to infinity yk is nothing but limit z tends to 1 z minus 1 capital Y of z. Okay, so for this we will skip the proof, not that much necessary. We have to use this theorem for solving examples only. So what this theorem says that if yz, what is yz? Yz is my, what is yz? It is z of yk. If yk is a sequence, z transform of yk we denote by capital Y of z. So if z transform of yk exists for mod z strictly greater than r, then y0 initial value is nothing but limit z tends to infinity Y of z. It directly follows from the definition of z transform only. And for B part, little bit calculation is required. So we are omitting that one. And what is B part? If again z transform of yk exists and z minus 1 Y of z is analytic at z is equal to 1. Okay, and here r is equal to particularly 1, then limit k tends to yk is nothing but limit z tends to 1 z minus 1 Y of z. So for this we will verify one example. Verify the above theorem for the sequence yk is equal to 1. What is z transform of yk is equal to 1? It is z upon z minus 1, right? Z transform of yk is equal to 1. Can you hear me, students?
Yes, ma'am.
Ma'am.
So, yes. Yes, any doubt? We have to verify this theorem for yk is equal to 1. So we want to show y0 is equal to limit z tends to infinity yz. So first, what is yz? If yk is equal to 1, then we know that y of z is nothing but z upon z minus 1
Z.
mod z is strictly greater than 1. This already we have shown. Capital YZ. So what I want to show y0. What is y0? And what is y0 in this case?
Minus 1.
Minus 1. This sequence is yk is equal to 1. Means what? What is the sequence? Yk is equal to 1 for k is equal to 0 to infinity. What is y0 then?
1.
Yeah, it is a constant sequence, na? It is a constant
Yes,
sequence.
sequence.
It's every value 1. Y0 is 1, y1 is 1, y2 is 1, and so on. 1, 1, 1, 1, 1, 1, and so on. Am I right?
Yes, ma'am.
If yk is equal to k, what is that sequence?
1.
Sequence, I am saying. 1, 0, 1, 2, 3, and so on. If yk is equal to k is a sequence. If k square, then 0, 1, 4, 9, and so on. Right? So this notation is sequence. Yk is equal to 1, nothing but, or in real analysis, how we write? Yk is equal to 1, k is equal to 0 to infinity, na? Right? 1, 1, 1, 1, 1. So here y0 is 1. Now we want to show that y0 is nothing but limit z tends to infinity y of z. So what is LHS? LHS is my y0 and it is equal to 1. What is RHS? What is RHS? Limit z tends to infinity capital Y of z. What is limit z tends to infinity z upon z minus 1? What is z tends to infinity z upon z minus 1? It is 1. And second one is if yz exists for mod z greater than 1 and z minus 1 yz is analytic, we want to prove this. So for second part, this is my A. What is my B? LHS is, what is that? Limit k tends to infinity yk. Limit k tends to infinity yk. What is limit of that constant sequence? 1, 1, 1, 1, 1. What is as k tends to infinity? 1 only, no? And what is RHS? Limit z tends to 1, z minus 1 yz. Limit z tends to 1, z minus 1 of yz. What is limit z tends to 1, z minus 1? What is yz? Z upon z minus 1. So it is nothing but 1. So LHS is equal to RHS. So here also this implies LHS is equal to RHS. Is that okay?
Yes, ma'am.
We'll go to next theorem. If Z transform of YK is equal to capital YZ for mod Z strictly greater than R, then for constant A not equal to 0, then for constant A not equal to 0, Z transform of A raised to K YK is nothing but capital Y of Z by A for mod Z is strictly greater than mod R times mod A, or mod A times R. So if yz is z transform of yk, then we want to show z transform of a raised to k yk is nothing but y of z by a. So just we will do this by taking, we know that by definition, what is z transform of a raised to k yk? By definition, what is z transform of a raised to k yk? Summation k is equal to 0 to infinity a raised to k yk divided by z raised to k. Now this I can write as k is equal to 0 to infinity yk
Z of
z by a raised to minus k. Is it right?
yes, ma'am.
So what is this? This by definition then what is, where is that? What is my y? I can write here. What is yz? It is z transform of yk. So by definition, this is k is equal to 0 to infinity yk divided by z raised to k, or you can say summation k is equal to 0 to infinity yk z raised to minus k. So whenever here z raised to minus k. Now here z by a raised to minus k. So this can be written as y of, this is nothing but capital Y of z by a. We'll take an example. Find Z transform of 3 raised to k sine of 4k. So this is of the form a raised to k yk, a raised to yk. So we will use this theorem, above theorem. We know that or Z transform of a raised to k yk is nothing but capital Y of Z by a. So what is so therefore what is Z transform of 3 raised to k sine 4k? What is 3 raised to k sine 4k? It is, what is yk here?
Sine 4k.
Here a raised to k is 3 raised to k, right? And what is yk? It is sine
Sine 4.
4k. So what is my capital Y of Z? If yk is sine 4k, what is capital, what is Z transform of sine 4k? We have already calculated this. Z transform of sine 4k. Z sine Z. Sine A. What is that?
Z sine A.
Z sine A divided by
Z square minus
Z square minus
2Z cos A
Sine
plus 1.
2
Z sine A
cos
plus 1.
2 cos A Z plus 1 na.
हाँ मैम.
First, yeah, this is my Z of Z transform of sine AK. Z transform of sine AK is nothing but Z sine A divided by Z square minus 2 cos A Z plus 1, right? This one. So using this, Z square minus 2 cos A Z plus 1, and this I can write in bracket. Is it right? So this is my YZ. Now by this, what is Y at Z by 3 then? A is A is 3 na. Here A raised to K is 3 raised to K means A is my 3. So Y at Z by 3 will be what? Y at Z is equal to this one. So Y at Z by 3 will be what? Z by 3 sine
4k.
A is my sine AK. आता इथे sine AK means इथे 4 पाहिजे. Is that right? Sine 4 divided by Z square by 9 minus 2 times cos AZ. Cos AZ means cos 4 Z by 3 plus 1. Is that okay?
Yes ma'am.
Here, this A is different. Here A is different. Okay. So just simplify this. Whatever will be this. If I simplify, this can be written as 3z sine 4 divided by z square minus 6z cos 4 plus 9. Is that right? 9 take LCM.
Yes, ma'am.
Yes, ma'am.
9 goes to above, then 9 by 3 is 3z sine 4 z square minus 6. इथे तीनाने मल्टिप्लाय करावं लागेल. 6 cos 4z plus 9. Is it right? So we have seen how to solve first order initial value problem. Now we will take one example of second order initial value problem. Solve second order initial value problem. Yk plus 2 plus yk is equal to 10 times 3 raised to k. Since it is second order, it will have two initial values. Y0 is equal to 0 and y1 is equal to also 0 given. Y0 and y1. Two initial values we will require. Y0 is equal to 0 and y1 is equal to also 0. So we want to solve this second order initial value problem using Z transform. Z transform. So taking here given difference equation is yk plus 2 plus yk is equal to 10 times 3 raised to k. Now taking Z transform on both sides. On both sides. What we get? Z transform of yk plus 2 plus Z transform of yk, which is equal to 10 times Z transform of 3 raised to k. So what is Z transform of yk plus 2? Yesterday only we have seen yk plus 2. Z square Z of yk means yz minus y0 z square minus y1 z. Is it right? This is Z transform of yk plus 2. Yesterday we have seen this.
Yes, ma'am. Yes, ma'am.
Yes. So this we will use. So I can write directly z square z yz or z of yk minus y0 z square minus y1 z plus this is nothing but z of yk. Yz leave the z of yk. Okay. I will write z of yk only. There we have written yz, right? Or yz we can write. What is z transform of 3 raised to k? Z upon
Z by Z minus 3.
z minus 3. So yz we have to take common. So z square plus 1 yz minus y0 is 0 na, y0 is 0, y1 is also 0. So 0 minus 0, which is equal to 10z upon z minus 3. So this implies yz is nothing but 8z upon z square plus 1 z minus 3. Is that okay?
Yes, ma'am.
10z upon minus 3 z square plus 1. Now we cannot do directly here inverse transform because we don't know the formula directly. So we have to use here partial fraction. So by partial fraction, ten z divided by z square plus 1 z minus 3. I can write this as a upon z minus 3. So z square plus 1 bz plus c. Z square plus 1. Do you know this partial fraction method, right? When it is square,
Yes,
then
ma'am.
bz plus c. So now simplify and tell me what is the value of a, b and c. Simplify this. Bz c z minus 3. Simplify and tell me what is a, b and c. What is the value of a? Are you doing?
Yes, ma'am.
Yes.
What is a, b and c?
A1
A is 1. Yes.
and B minus 1.
A is 1. B is minus 1. C?
Yes, ma'am.
What is C? C also we want now.
A is equal to 3, B is equal to minus 3, and C is equal to 1.
C is equal to
C minus 3.
minus 3.
3.
Yes. A is equal to 1, B is equal to minus 1, and C is equal to minus 3. Everybody is
Yes.
getting this? So I can write 10z divided by z minus 3 z square plus 1 as A is my 1. 1 upon z minus 3 minus minus z plus 3 divided by z square plus 1 I can write. This implies this one. So what is y of z? Therefore, y of z is nothing but 1 upon z minus 3 minus z minus 3 upon z square plus 1. Okay, and z plus 3 divided by z square plus 1. Whether everybody is getting that answer? I think
No, ma'am.
1 upon पाहिजे ना ते 10 up 10 times. So z yeah you Mohammed, how you are getting a is equal to 1, b is equal to minus 1 and c is equal to minus 3? If it
Yes,
is
yes,
10,
ma'am. Yes, but Z outside
z should
and
be outside.
equation only equal to 10.
Yes, z. So z
10
should be
only.
outside.
Yes,
Yeah, otherwise you won't get that one.
yes,
So 10 is equal to only you have to do.
yes.
Now it is okay. Now check.
Yes, 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 ma'am.
Yeah, let others check.
Okay.
Poonam,
Yes, ma'am.
हा आता बरोबर आहे का? आता येत आहे तुमचं?
नाही मॅम, फक्त जेवढं टाकलं होतं तर माझं a is equal to 3, b is equal to minus 3 and c is equal to 1 आलं होतं.
ओके, तुम्ही एबीसी चेंज केलं का? ए अपॉन झेड
नाही
स्क्वेअर प्लस 1 घेतलं का तुम्ही?
नाही, तुम्ही जे दिले तेच घेतलंय. 10z is equal to 30.
So you can just simplify this, no? नाही येते का करून दाखवू?
नाही नाही मॅम, करतो.
What about others? Just you have to compare the coefficients. Az square plus a plus bz square plus cz minus 3bz minus 3c is equal to 10. So whatever constant terms is equal to 10 and remaining coefficient of z square will be 0 and coefficient of z also you have to take as 0. येते का सगळ्यांना का मी करून दाखवू? bz square minus 3bz plus cz minus 3c. So this 10 I can write as 10, 10 or 0 times z square 0 times z plus 10 is equal to, now collect the terms a plus b times z square Z minus 3b plus c times Z, and what is constant plus a minus 3c, right? Is it right?
Yes, ma'am.
So what this
Yes,
now
ma'am.
comparing coefficients of Z square, Z and constant. We get what we get? A plus b is equal to 0, uh, minus 3b plus c is equal to also 0, and what is a minus 3c is equal to
10.
10. Yeah. So which I can solve. A is equal to minus b, I can substitute. So this, from this, a is equal to say minus b. So minus 3b plus c is equal to 0, and here you, in this you can substitute a is equal to minus b. So minus b minus 3c is equal to 10. Now solve this two. Okay, so minus 3b plus c is equal to 0, minus b minus 3c is equal to 0. So what will be there? 3 times I have to multiply for this. So minus 9b plus 3c is equal to 0. Minus b minus 3c is equal to 0. Multiply by this. So this 3c, 3c.
And
Yes.
minus c is equals to 10 आहे ना?
Minus
B minus 3c is equals to
10, 10, 10. इथे 10 आहे. Minus b minus 3c is equal to 10. Right. So my minus 10b is equal to 10. So what this implies? B is equal to minus 1.
minus 1.
Now if b is equal to minus 1, therefore a will be 1. Right? A is equal to minus b. And what is my c? Minus 3b plus c is equal to 0. Minus 3b plus c is equal to 0 implies c is equal to 3b. So this implies c is equal to minus 3. Right? C is equal to minus 3, b is equal to minus 1, and a is equal to 1. Is that okay?
Yes, ma'am.
So yz is nothing but z times this. So again, the, yz can be written as z upon z minus 3 minus z square upon z square plus 1 minus 3z upon z square plus 1. Is that okay? Now taking inverse transform. But before again taking inverse transform, I need to convert into the proper format. So now this again I can write as z upon z minus 3, no problem. It will be just 3 raised to k. For this z square, I will write z square minus z cos pi by 2. I can write. I have to rewrite so that I should get its z square minus z times cos pi by 2. What is cos pi by 2?
0.
Yeah, so I can write it. Okay, since it is 0 only, I can write z times cos pi by 2, and z square minus 2 times z cos pi by 2 is also 0. So z square plus 1 I can rewrite like z square minus 2z cos pi by 2, right? You
Yes,
can
ma'am.
and z square plus 1 also I can write it z square minus 2z cos pi by 2 plus 1. And this minus 3z. Again for this I want to write 3z sine pi by 2 divided by z square minus 2z, it is cos pi by 2 plus 1 I can write. Can I write like this? Z
Yes, ma'am.
also I can z is equal to z times sine pi by 2. Sine pi by 2 is 1 and z square plus 1 again we have written the same way. Now taking inverse transform on both sides. Now taking inverse z transform on both sides. We get, what is this? Yk is equal to, this is for 3 raised to k minus, what is this? Cos of pi by 2 k cos ak. This is z transform of cos ak. And what is this? Minus 3 times sine ak. Ak a is my pi by 2. Is that right? Z transform of cos pi by 2k is this one. And Z transform of sin pi by 2k is this one. 3 outside. So 3 times sin pi by 2k. And Z transform of 3 raised to k is Z upon Z minus 3 only. Is that okay? Any problem? Just calculations are required in this Z transform. Shall I go further? Last example, or I will do this later. First we define convolution of sequence. The convolution of two sequences UK and VK is denoted by UK convolution with VK, and we UK convolution with VK is nothing but summation K is equal to M is equal to 0 to K UK minus M BM. If I write this as sequence, or briefly we can write UK convolution with VK is nothing but summation M is equal to 0 to K it is like convolution theorem in Laplace transform and Fourier transform is there, right? Convolution of two sequences UK and VK is given by this one. Summation M is equal to 0 to K UK minus M VM, because here sequences in Laplace transform and that we are taking functions. We are dealing with functions. Here now sequences, so UK sequence convolution with VK is summation M is equal to 0 to K UK minus M VM. So if this is the convolution, there is a theorem convolution theorem. If capital U of Z exists for mod Z greater than A and capital V of Z exists for mod Z greater than B, then Z transform of UK convolution with VK is nothing but capital UZ, capital VZ. What is capital UZ? It is Z transform of UK, and capital VZ is nothing but Z transform of VK. For modulus of Z is strictly greater than max of A comma B. This is the convolution theorem. This also without proof we will consider. Now from this theorem, since summation M is equal to 0 to K Ym 1 star, I can write as 1 star Yk. Can I write like this? Summation M is equal to 0 to K Ym is 1 star Yk, because whatever may be your another function, UK minus M you can consider as 1, and VM also, VM will be your Yk type. So I can write 1 star yk. Therefore, Z transform of summation m is equal to 0 to k. Ym we can write as Z transform of 1 into Z transform of yk. So Z transform of 1 is Z upon Z minus 1 and Z of yk. Is that okay? Are you there?
Yes, ma'am.
Yes, ma'am.
So we can write the corollary form. If Z transform of yk exists for mod z strictly greater than r, then Z transform of summation m is equal to 0 to k yk ym can be written as Z upon Z minus 1 Z of yk for mod z greater than max of 1 comma r. From this theorem only, convolution theorem, it follows. Take one example. Find Z transform of summation m is equal to 0 to k 3 raised to m. So by above corollary, what is Z transform of summation m is equal to 0 to k 3 raised to m? It is z minus 1 z of yk. Right? What is yk here? Yk is nothing but 3 raised to k. So z upon z minus 1 z transform of 3 raised to k. So what will be this? Z upon z minus 1 and z upon z minus 3. So I can write this as z square z minus 1 z minus 3. So this is for mod z strictly greater than 1 and maximum of 1 comma 3. Means 3. Maximum of 1 comma 3 is 3. So I can directly write here 3. Is that right? Is it okay? So whenever we want to deal with summations, we use this formula. Last one thing I will give for homework. Solve the system using Z transform. Solve the following system by Z using Z transform. So two system of equations has been given. uk plus 1 minus vk is equal to 3k 3 raised to k k times 3 raised to k. and where u0 is 0 and v0 is 3. You can take this as homework. Can you solve this? You have to take Z transform on
Yes,
both
ma'am.
sides, and then you have to just solve two algebraic equations in two unknowns, capital UZ and capital VZ, and find UZ and VZ. Then take inverse transform to find UK and find VK. Can you do this?
Yes, ma'am.
Okay. It is like just system of equations now too. So this completes our Z transform. Another so the with this exercise again another homework you can take. Page number 120, exercise 3.11 A. And 122 exercise 3.119. Exercise 3.120 A. Second order. That much is enough for. So this completes our Z transform and chapter 2 also. Yeah, chapter 2. Chapter 3. Now we will start chapter 4. So it is in unit 3 only, stability theory. So that will be like new topic, stability theory. Is that okay? So you try to solve this using Z transform. These all exercises are depending on Z transform only. Simple exercises. For practice, you solve these examples. Is that okay?
Yes, ma'am.
So we can stop here, and tomorrow we can start that stability theory. Tomorrow also we will have lecture. Okay, tomorrow, day after tomorrow. Is any problem? For tomorrow's lecture, I will share the link.